Alright, so something in algebra we do a lot is we solve equations. And typically we're, solving for a variable. So we solve for x or we solve for y. Well, I want to talk in this video about what if you have two variables in your equation. Two variables makes this thing a little bit more complicated. So instead of having like something like this, 3x plus 2 equals 8. This is an example of a one variable equation. If we were going to solve for x, we would start doing all of our math. I'll put a little line down the middle here. You'd start moving everything around, and at the bottom you're going to get x equals, and you're going to get an answer. You're going to get some number. Oops, that's a terrible number sign. But that's what ends up happening, is you get some sort of a number down here, and that makes you happy, and you got your answer, and you're all done. Well, two variable equations are when you have not only an x, but some other variable, maybe a y. So like 3x plus 4y equals 8. This is a different story. Now when you go to solve, you're not going to be able to get to the bottom and get one answer, because what are you solving for? X or y? You don't know. So you need a little bit more directions. You need someone to tell you which variable you need to solve for, and then usually your answer is going to be kind of messy. So I'm going to flip the screen here. Here is a two variable equation. 6x plus 3y equals negative 12. Now I could tell you a couple of things about this equation. First off, I could tell you that this equation is, I'll draw an arrow here, represents a line on a graph. And I could ask you things like find the slope or find the y-intercept. And the easiest way for us to find slope and y-intercept is the typical y equals mx plus b. That's what we're so used to. But this does not look like y equals mx plus b. So what we're going to do is we are going to solve for y. We want to make it look like y equals mx plus b. And so to do that, we got to do some steps. So to solve for y means at the very bottom down here, we're going to have a y equals answer. So anything that's not a y probably should not be on this side of the line. So like the 6x over here, my first instinct is to say let's move it over to make it a negative 6x. So let's get rid of that. So we have 3y equals negative 12 and negative 6x. Well, we can't put those together. They're not the same thing. They don't both have x's. So I'm just going to write we have a negative 6x and a minus 12 on this side. Can't put them together. And then we want y by itself. We want to solve for y, so we're going to divide this 3 away. But that means we're going to have to divide the entire other side by 3. Both sides are going to divide by 3. And so then we're going to get the 3's to cancel, and we're going to get this y equals, which is what we want. And we're going to have two things to divide. We're going to have negative 6x that we have to divide by 3. And then we're going to have minus 12 that we're going to have to divide by 3. And conveniently, both these divide pretty evenly. Negative 6 divided by 3 is negative 2x's. Minus 12 divided by 3 is 4. So we get it all the way down to this, and this is our answer. This is our solve for y. Y equals negative 2x minus 4. So I could answer all those questions like, well, what's the slope of the line? Well, now you'd look at it and say mx plus b. M is negative 2 and b is negative 4. So if anybody asked me what the slope is, I'd say the slope equals m. And m equals negative 2. So we have a slope of negative 2. And that kind of a thing. And we can do this for things with not x's and y's, but this is just a really nice example to kind of show you where solving for y has a purpose. At the end, when you're done, you can easily find y equals mx plus b and find the slope. So maybe you should pause the video and try this one and see if you can do it. I'll go through the steps here and kind of show you. So line down the middle, we need some direction. So let's say solve for y. So we know which variable we're solving for. And if I'm told to solve for y, then I know down here at the very bottom I'm going to have a y equals answer. So anything that's not a y, I got to start moving around. So I'm going to start with the 2x here, the minus 2x, move it over, make it a positive 2x. Which means I'm left with 5y equals a positive 2x and 25. So I can write 25 plus 2x, or I could write 2x plus 25, either way. And then my next step looks like I'm going to need to divide. So I'm going to divide by 5. And I'm going to divide all of this by 5. Which then means I'm left with 5 divided by 5 to cancel. And I get y equals, and I'm going to break this up into two separate division problems. I'm going to do 2x divided by 5 plus 25 divided by 5. 2 divided by 5 is a decimal. I know 2 divided by 5 is a decimal, but I don't really care about turning it into a decimal. I'm going to leave it as 2/5, like a fraction. So I have a 2/5 x plus 25 divided by 5 is 5. And now I got my answer. And I can leave it just like that. Now if someone came around and said, you know, what's the slope of this line or something like that, I could easily identify it as 2/5. And I would say, you know, my slope m equals 2/5. We know on a graph that that is technically the rise and the run. So it must be a graph that goes up 2 over 5 between the points. So rise and run is 2/5, kind of a thing. So these are kind of examples of, you know, what I would say is kind of relatively easy two-variable equations. They can get more difficult. Check this next one out. I want to do the same exact directions. I want to solve for y. So I'll write it up here. Solve for y. Well, I'm going to line down the middle. I know at the bottom I want a y equals answer. But the y's, notice they're on both sides and they're kind of buried into this problem. So we're going to have to do some work to get them together. Starting probably with my very first step here. I'm thinking we better start with this negative sign. And we better distribute it in. So we're going to have this 3 out in front. And we're going to distribute the negative to the 2x. So we're going to have a minus 2x. And then the negative with the y is going to make it a negative y. And it's going to equal 6 minus 2y. And I want the y's together on the same side. So why don't we add this 2y over, make it a positive 2y. And we're going to have this 3 minus 2x, so we'll rewrite it here. 3 minus 2x. Negative y plus 2y is a positive 1y. And it equals, now this is gone, so it just equals 6. So let's get some more stuff together. Let's take this 3 and move the 3 over to make it a negative 3. 6 minus 3 can go together. 6 minus 3 is 3. So we have negative 2x plus 1y, or I could just say plus y, I don't need the 1 there, equals 3. And if I add the 2x over to the other side, make it a positive 2x, I'm going to be ready to get an answer. If the 2x flips over, I get y equals 3 plus 2x. So a 3 plus 2x, or I could say 2x plus 3, either or. And there is my answer. Multivariable equations. They're kind of fun, but you have to play around with them. And the directions, you got to pay really close attention to this thing up in the corner, because I could have said solve for x, and then it would have been a totally different story. I would have had to have an x equals down here at the bottom instead of a y equals. So pay attention to the directions, and we'll practice these in class.